Forest Technology Systems Limited is an environmental monitoring technology company that provides equipment to automate the collection of meteorological and hydrological data to governments. Fire weather is still the largest business unit, and FDS equipment is used for the largest network of dedicated fire weather monitoring equipment in the world. FDS is based in Victoria, BC, Canada, with a branch office in Blaine, Washington, USA. History: FDS was founded in 1980 by Bill Cave, a Canadian Forest Service research technician. Cave leveraged the microprocessor to create the WR61 data logger, a battery-powered weather data recorder that allowed for the automated collection of weather data. In 1981, FDS sold its first commercial product, the TS4000. Previously, weather data collection in British Columbia was completed manually, with technicians required to go to remote locations to collect samples from instrument shelters, known as Stevenson screens. In 1982, the BC Ministry of Forestry purchased several of the WR61 and WR62 data loggers from FDS, enabling the automated collection of weather data. The automated process made it possible to collect additional data as the units were left on site and the data collected at a later date. In 1984, FDS developed the RM4000, the first radio modem to integrate a customer's handset inside a ruggedized case. The modem operated at 600 baud and made it possible to retrieve data without physically visiting the weather station. In 1994, to gain entry into the U.S. fire weather network, FDS created the FWS-11 data logger to fully comply with the standards outlined by the National Fire Danger Rating System. In 1998, FDS entered the hydrology market, delivering a system of data loggers and sensors capable of monitoring hydromet and hydrology, with a focus on continuous in-stream turbidity and sediment monitoring. Since 2000, FDS has become fully ISO 9001 certified, the first to integrate GPS technology with GOES communications, and began distributing the G4 GOES transmitter, the first to offer high data rate transmission speeds. They have released the Axiom F6 data logger, the only fire weather data logger with an integrated touchscreen and standardized USB ports for data input and output and software updating. In 2012, FDS released a CS2-capable GOES transmitter to comply with changes introduced by the National Oceanic and Atmospheric Administration. Company profile: while fire weather was the initial focus, the hydrology market is now the fastest growing. FDS also acts as a system integrator, providing knowledge and products to build systems and networks for a wide variety of meteorological applications. Clients: FDS has created partnerships with multiple levels of government as well as within the private sector. FDS stations are in use by every one of the top 50 government forest management agencies throughout Canada and the United States, including Fire Weather Clients, Alaska Fire Service, BC Ministry of Forests, California Department of Forestry and Fire Protection, U.S. Forest Service, U.S. Fish and Wildlife Service. Hydrology Clients: USGS, New Mexico, Washington State Department of Transport, the Water Survey of Canada, Minnesota Department of Agriculture. Meteorology Clients: Parks Canada, Mexican Navy, Texas Forest Service and United States Army Corps of Engineers. FDS has cultivated a relationship with the BC Ministry of Forests, resulting in the creation of Canada's largest all-FDS fire weather monitoring network, with 225 stations collecting and contributing data for long-term climate and weather monitoring. technology. FDS provides solutions to help monitor and track environmental conditions, allowing governments and corporations to use accurate data to predict forest fires and monitor water quality. RAWS, for long-term, remote monitoring of weather and other environmental conditions. FDS has designed, developed, and deployed reliable remote automated weather stations for clients around the world. These fixed units are purpose-built systems made up of components specifically designed to reflect each weather station's and monitoring team's individual needs. The FDS fixed RAWs are able to measure solar radiation with a pyranometer, monitor fuel moisture and temperature through an optional fuel stick, monitor wind speed and direction, gather accumulated precipitation readings through a tipping bucket, measure current air temperature and relative humidity, recharge the heavy-duty battery through solar panels, transmit data through the GOES satellite. The data is recorded by a data logger and the information is transmitted to the customer's computer system, eliminating the need for on-site data collection. Portable RAWs. The FDS Quick Deploy RAWs are designed to be used in temporary locations, offering the same full suite of monitoring applications as the fixed RAWs in a portable unit. These self-contained systems can be set up in as 15 minutes by one person, and do not require any tools. The QD systems are commonly used to monitor weather conditions during prescribed burns. Fire danger rating. Fire danger indices are used throughout the world to provide land management agencies with the accurate data required to determine the estimated likelihood of fire danger within a specific geographical area. The data used to calculate fire behavior includes fuel conditions, local topography, and immediate and historic weather conditions. The National Fire Danger Rating System is used throughout the United States to provide an accurate assessment of the possible burning conditions for various regions. Typically, the fire danger rating scale is represented through the use of relevant colors and a simple description. Low, unlikely that fuels will ignite. Moderate, number of fire starts predicted to be low, and unlikely to become serious. High, fires may spread rapidly with increased intensity. Potential to become serious and difficult to control. Very high, fires may start easily and spread quickly. Light fuels take on characteristics of heavier fuels, burning quickly and intensely. Extreme, fires start quickly and easily, spread rapidly, and burn intensely. Fires at this level are difficult to control and require specialized tactics and effective planning. To determine an accurate fire danger rating, data acquired through RAWs is sent to the NFDRS processes. There are 3 different types of processes used to handle this data. A central server used by multiple agencies, the Weather Information Management System. Private software for office use, such as Fire Weather Plus or Weather Pro. Interagency software of office use, Fire Family Plus. WIMS is used by most federal and state fire management agencies to determine the daily fire danger rating. FDS RAWs transmit hourly fire weather data via satellite to the WIMS server, which is stored for 18 months. The relevant information, including min, max temperatures and relative humidity, are archived in for future use. The hourly observation data collected from RAWs and AWS is also archived at the Western Regional Climate Center in Reno, Nevada. Turbidity sensor. The FDS DTS-12 turbidity sensor is designed to operate for prolonged periods, regardless of the hydro environment. This digital sensor uses a laser diode light source to measure turbidity. and includes a self-cleaning wiper to ensure accurate readings for up to 12 months, and cleaning cavities that prevent sediment from obscuring the optical face of the sensor. A recent German study employed 40 FDS-DTS-12 sensors during a 4-month campaign to study the potential and effectiveness of a system used to monitor suspended sediment dynamics.